Welcome, everyone. My name is Juan Yu. I'm an analytics specialist solution architect at Amazon Web Services. In this session, my colleague Tiagarajan Arumugam, Principal Analytics Solution Architect, and I will help you navigate your big data journey with AWS Big Data Services. Today, we will cover data lake concept, how to build, secure, and run analytics on AWS Data Lake to serve your big data project. Then we will demonstrate a big data solution. Start from ingesting data to data lake, running ETL, then analyzing data in data lake, using BI tool to visualize data and gain insights, and run forecasting. After demo, we will answer questions. With data era, big data solution becomes more and more popular. However, the impression is often it's too complex. It's very hard to make it right. Let's take a look at common challenges in big data solutions. With social media, digital devices, smart home, data grows exponentially. Our original iPhone in 2007 had 4 GB memory. Today, you can get 1 terabyte of storage on a cell phone, and every year they just keep increasing. Similar scale we observe with organizational data. Data is stored in data silos, not centralized. It's very hard to get a full picture. More and more data sources come up every day. You want to use a broader set of tools to analyze different types of data and move faster to gain insights. In the meanwhile, business needs to balance democratization of data with governance and control. You want to provide the right data in the right format for machine learning and model training. So there are some common challenges to build a big data solutions. We hear from companies all the time that they're looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially, coming from new sources, is increasingly diverse, and needs to be securely accessed and analyzed by any number of applications and people. There are many people in every business who are involved in analytics daily, and each of these users has a different perspective. An application developer may need to analyze logs to find where the bottleneck is. A product manager wants to build a dashboard to monitor customer behavior and product trend. IT team want to have a central unified control for security and governance. Very often, a user may take multiple roles. It's very important for anyone who's working in big data field to understand the whole process of building big data solutions and make cross-team collaboration easier. Analytics is a broad space. There are many different use cases. Daily reporting from multiple data sources, social media analysis, learning customer online shopping behavior, analyze operational data to predict risk and issues. Those use cases emerge for most businesses which require a central data storage, integrated with various analytics toolset called data lake. A data lake is a centralized repository that can store both structured and unstructured data. Data could come from many different data sources, including batch data and streaming data from web applications, digital device like camera. Common open source file formats such as Parquet are preferred, Because if a new tool comes up that can process the data much faster, you want to leverage the new tool as soon as possible, instead of being locked in proprietary format. Data Lake enables analytics in place with a wide variety of toolsets, including frameworks such as Apache Hadoop, Apache Spark, machine learning toolsets. AWS helps organizations quickly get from data to answers by providing mature and integrated analytics services, range from cloud data warehouses to serverless data lakes. Getting answers quickly means spending less time building plumbing and configuring cloud analytics services to work together. AWS helps you to do exactly that by giving you an easy path to build a data lake and start running diverse analytics workloads. AWS Data Lake provides secure cloud storage, compute, and network infrastructure that meets the specific needs of analytics workloads. It's a fully integrated analytics stack with a mature set of analytics tools, covering all common use cases and leveraging open source file format and standard languages, engines, and platforms. And it provides the best performance, the most scalability, and the lowest cost for analytics. The AWS Cloud provides many of the building blocks required to help customers implement a secure, flexible, and cost-effective data lake. This includes AWS Managed Services that helps ingest, store, find, process, and analyze both structured and unstructured data. Amazon Simple Storage Service is the heart of Data Lake. S3 provides a fully featured storage layer alongside both a comprehensive compute layer and a network stack with the speed and scale needed for advanced analytics. Building a data lake on this robust foundation allows customers to store all of their data without worrying about what to throw away, and it reduces the cost needed to do analysis on that data. AWS provides a diverse and mature set of analytics services that are deeply integrated with the infrastructure layers, allowing you to easily take advantage of features like intelligent tiering and easy-to-spot instances to reduce the cost and run analytics faster. When you're ready for more advanced analytics approaches, our broad collection of machine learning and artificial intelligence services can be used against that same data in S3 to provide even more insight without the delay and cost from moving and transforming your data. S3 is also integrated with a broad set of data ingestion services, allow you to move large amounts of data in bulk, or load streaming data, and enable near real-time analytics with existing business intelligence tools and dashboards, or migrate data from your on-premises database data warehouses. AWS Lake Formation enables secured self-service discovery and access for user without having to ask IT to find and grant access to data. Lake Formation is aware of multiple analytics services and provides easy on-demand access to specific resource that fits the processor and memory requirements of each analytics workload. The data is curated and cataloged, already prepared for any flavor of analytics, and related records are matched and deduplicated with machine learning. This automation greatly reduces the time it takes to get to answer when your data lake is built on top of AWS. Now let's hear how our customers leverage AWS Data Lake. Georgia Pacific produces hundreds of paper and tissue parent rolls every day. and converts those parent rows into consumer-ready bath and tissue products. Traditionally, the company had relied on many separate sources covering attributes like material quality, moisture content, temperature, machine collaboration, as well as a small team of set-specific experts with tribal knowledge to manage and anticipate machine maintenance requirements. Downtime of machines can cost millions of dollars per year per line. To address the requirements for new data insights and less complex data collection, Georgia-Pacific implemented an operations data lake for advanced analytics, using Kinesis to stream real-time data from manufacturer equipment into the data lake, then transforming with EMR and analyzing the data with Amazon Redshift and Amazon Athena. The data lake brings lots of benefit to Georgia-Pacific. Just to highlight a few. Leveraging the data lake, they can predict equipment failure 60 to 90 days in advance, reducing unplanned downtime, saving a lot of money. They can run more production lines in a predictable manner, better optimizing human and capital resources. Another customer use case is Wood.com. They leverage AWS Data Lake to reduce the operational cost by nearly 90%, as well as the support requirements. The data lake enables their team more opportunities to experiment with new technologies, to move in faster, be more agile. Many enterprises choose AWS Data Lake as the foundation for their data and analytics architecture. AWS is focused on helping customers build and secure data lakes and data warehouses in the cloud in days, not weeks. Now I'm going to hand to my colleague Thiagarajan, who will discuss the common data lake patterns our customers implemented and the key analytics services you can leverage to build and access data lake.
Hey everyone, I am Thiagarajan Armugam, Principal Solution Architect at Amazon Web Services. So in the rest of this presentation, I'm going to talk about some of the common data lake patterns and how you would go about performing analytics on Amazon Web Services. So we're going to talk about the building blocks for the AWS-based data lake and also dive into some of the analytical services that you would be able to use to go and analyze the data on the data lake. Amazon S3 provides a storage foundation for the data lake on AWS. It is a fully featured storage layer alongside both a comprehensive compute layer and a network stack with the speed and scale that is needed for performing advanced analytics. Building a data lake on this robust foundation allows customers to store all the data without worrying about what to throw away, and it also reduces the cost needed to do analytics on that data. So as you see in this presentation, you see that data is organized in the data lake in multiple tiers. So what you got is the raw data, that is the landing zone, where the data arrives from different sources, such as the OLTP or the transactional sources. And the data gets then cleansed and formatted, and which is stored in a different bucket. And you also have the confirmed data, which is essentially the data that's used by the business or your end users to go and analyze the data. So you would be able to organize the data into different tiers and then be able to effectively perform analytics on the data. Another important component of the data lake is the data catalog. So for the data lake to be usable, it needs to have a defined mechanism to catalog and index the data. So what we got is AWS Glue, which can automatically crawl the data lake and construct a single view across all the data sets to make it easy for end users to discover the relevant data to perform analytics and provide insights on the quality of the data. AWS Glue is a fully managed service that provides a data catalog to make data discoverable and also allows the data to be extracted, transformed, and loaded, essentially being prepared for analysis. So essentially you would be able to perform ETL on that data. For example, in this illustration, let's focus on the orders data. So what you have on the left-hand side is the orders data that is coming in from your different databases. And the orders data gets imported as it is into a raw form. And then you'd be able to then perform a cleansing operation on the data using the ETL operation provided by AWS Glue. And then you would be able to create the cleansed tables, which are the C orders, from which you would be able to transform the data to create the curated set of tables, which are the D_orders table, which essentially are being accessed by your end users for doing any analytics. So to make the data creating into different tiers, so you would be able to also use the lake formation service, which provides you blueprints in the form of pre-built templates, where you'd be able to automatically build the data, crawl the data, and also set up jobs to go and process the data. And at the same time, also, not only you would be able to create all this one time, but also refresh this data on a daily basis so that you have up-to-date data on the data lake. Another important foundation for the data lake is the security model. In AWS, security is the top priority. So what you got on the security is the AWS Identity and Access Management, which we call the IAM, which enables you to manage access to the AWS services and resources securely. Using IAM, you can create, manage AWS users, groups, and use permissions to allow or deny access to the AWS resources. For example, we talked about the different buckets that are created for storing the data in the data lake. So you'd be able to apply bucket policies that would define the different levels of access that you would for the individual objects inside the buckets that you would want to provide for your end users. To make this all easy and also provide fine-grained access control, lake formation allows you to set up fine-grained access control on the data lake objects very easily. The lake formation permission model is implemented as a DBMS style grant revoke kind of permissions, which allow fine-grained access to be set up on those individual objects in the AWS S3 based data lake. So the lake formation not only allows you to centrally manage the security, govern it, and also apply auditing policies on the data in one place, you'll be able to also access it multiple times, multiple ways, using different services. So once you set up all the access privileges on the lake formation, you'd be able to consume all that without needing to repeat all the setup on the access to the data from all these different services which are shown on the right hand side. For example, let's say you want to query the data you'd be able to discover the data that's there in the data lake. So, let's say you want to run a SQL on the data. You'd be able to use Amazon Athena to run a query. But when you run the query, you don't need to repeat the security model once more. So since it's all set up in the lake formation, all those permissions are also translated into the Amazon Athena as well automatically. So now we talked about the three different foundation blocks, which is the storage, cataloging, and the security associated with the data lake. Let's now talk about some of the analytical services that you would be able to use to go and analyze this data. So let's start with Amazon Kinesis. So Amazon Kinesis allows you to easily collect, process, analyze real-time data, streaming data, to get timely insights and react quickly to the new information. You can enable data ingestion and capturing of real-time streaming data, store it based on your processing requirements, and process to tap into real-time insights. And then you would be able to also react in the form of sending alerts, emails, notifications, or trigger event-driven applications. And finally, you'd be able to also land this data into a persistent layer, which is Amazon S3. Another interesting use case is the operational analytics. So you'd be able to use Amazon Elasticsearch service that makes it simple to collect, analyze, and visualize unstructured and semi-structured machine-generated log data from websites, mobile devices, servers, sensors, etc. You can use Elasticsearch to collect, index these log data, for example, and get real-time insights in terms of the trends and patterns, or even detect anomalies and resolve errors pretty quickly. For example, you'd be able to build a Kibana-based dashboard based out of Amazon Search Service, and then you would be able to get real-time insights into the data that's generated from your log files. For interactive analytics, Amazon Athena makes it easy to analyze data directly in S3 using standard SQL queries. Athena is serverless, so there is no infrastructure to set up or manage. You can start querying the data instantly, get results in seconds, and only pay for the query that you run. So with AWS, you'd be able to very easily perform serverless analytics. For example, we have an emerging serverless analytics track. This is an example of a serverless analytics track. So you could put together all these different systems together with zero infrastructure to manage. This lets you pay per use with close to zero costs when things are idle. And it also scales automatically. Systems are highly available and fault tolerant by default. For example, on your right hand side, what you got is on the bottom, let's say there are data that are emitted from your IoT devices. You'd be able to collect all the data using AWS IoT and then persist the data in Amazon S3 based data lake, and then be able to use AWS Glue to go and catalog and perform a data ETL operation and put the data, cleansed data back to Amazon S3, and then use AWS Athena to go and query the data using SQL. Further, you'd be able to extend this data to perform any kind of AI or ML analysis using AI and ML services, and also build simple BI dashboards using AWS QuickSight. Amazon Redshift is a data warehousing service that makes it simple and cost effectively run high performance queries on petabyte scale of structured data so that you can build powerful reports and dashboards using your existing business intelligence tools. Amazon QuickSight offers fast cloud-powered BI service that makes it easy to deliver insights to everyone in your organization. So QuickSight lets you create and publish interactive dashboards that include machine learning insights. And also, these dashboards, you would be able to access it from any device or even embed them into your applications, portals, or websites. AWS offers the broadest and deepest set of AI and machine learning services and supporting cloud infrastructure without needing the developer to have the machine learning expertise. You'd be able to extend the analytical data that you have built from the data lake to do things like demand forecasting, study the customer behavior, and improve upon it. We see the machine learning stack having three key layers. So on the top, what you have is the AI services, which are ready-made for all developers. So there are no machine learning skills that are needed. For example, customers say, here is an object, tell me what it is. Or here is a face, tell me if it's part of a facial group, using the Amazon recognition service. In the middle layer, what you got is the infrastructure layer. So AWS offers a broad array of compute options for training and inference with powerful GPU-based instances, compute and memory optimized instances, and even FPGAs. In the bottom layer is for the expert machine learning practitioners, essentially the researchers and developers. For example, AWS SageMaker makes model building and training easy by providing pre-built development notebooks. Popular machine learning algorithms optimize for petabyte scale datasets. On automatic model tuning, enabling developers to build, train, deploy models in a single click. Now, let's talk about an interesting customer story with Amazon.com data lakes on AWS. So Amazon builds and operates thousands of microservices to serve its millions of customers. These include data from catalog browsing, order placement, transaction processing, delivery, scheduling, video services, and Prime registration. So essentially the challenge here was Amazon needed to analyze massive amounts of data to find insights and identify opportunities with all the different business teams out there. So it had to operate a data lake in such a way that each of the business units would be able to independently operate on the data lake, at the same time very easily be able to scale up on the data sets. Scaling was one of the huge challenges associated with the previous monolithic data warehouse. And the data, as you could see, hugely grew. So it hugely grew from all the way from 50 terabytes to 100 terabytes. So managing that scale of data involved challenges with the legacy platforms. So the solution quickly, the solution that was deployed was a data lake on Amazon S3 that runs analytics with the different analytical services on AWS. For example, the Amazon Redshift for the data warehouse, Redshift Spectrum feature of the Amazon Redshift, EMR, and other analytical processing engines. So the benefit that was achieved was they were able to double the data that was stored from all the way from 50 terabytes to 100 petabytes. That lowered the cost and also allowed the customers to gain insights faster. So let's now look into a little bit deeper into this particular data lake implementation at Amazon.com. So on your left-hand side, what you got is the source systems, which emit the data. So essentially, the data could come from the DynamoDB, relational data sources, non-relational data sources, streaming sources, such as ClickStream. So you could have all these different data sets, data sources, and the data then comes into the central region, which is the S3-based data lake. So on the data lake, what you have is data discovery services, which could catalog the data and also allow administrating this data and also set up governance and security over this particular data. And once the data is set up on the Amazon S3, then the data could be processed and transformed using the analytical services such as EMR or Glue, and then to land the data back to the S3. So once you have the processed data, the end users of these data were able to easily subscribe to the data with any of the analytical services of their choice, depending on the use case, to do any further processing. So they could either consume the data through Redshift or EMR or other computational mechanisms to go and consume this data on a daily basis. So with Amazon.com using the AWS-based data lake, they were able to scale up the data sets to all the way from 50 terabytes to 100 plus petabytes, which is growing. And essentially, they were able to also process 600K analytical jobs that typically run on a daily basis to process this data. And this data lake also allowed each of the business units to scale independently, that lowered their overall cost and also allowed them a variety of technologies depending on the use case to be used. And the business users or data scientists can easily discover this high quality data in optimized formats, and teams are able to do all the reporting that reduce their latency for their analytical results.
Hey everyone, part of this demo, what myself, Tiago, and Juan are going to do is we're going to do a little bit of a role playing so that this demo is a little more interactive. So we are going to pretend we are going to be employees of this retail company called Red Imports LLC. So the Red Imports LLC is a e-commerce retail company that sells multiple goods using their website. And part of their big data journey, RIL moved into AWS, and RIL is operating a data lake that's powered by AWS. And For our demo today, what I'm going to do is there are two separate roles that we are going to play. I'm going to pretend I am a data analyst, and I'm going to help out my business users to get insights into the data that is there in the data lake. And I'm also going to show you some of the dashboarding capabilities that is available on the AWS. And Juan is going to help me navigate the big data journey using the RAL data lake on the AWS. So she's going to pretend as if she's the data engineer who is going to help me analyze all this data, get insights into this data, but it's there in the data lake, and also help me with getting this data into a form that I would be able to share it with the different business teams, data scientists.
Yeah, Tiago, I'm looking forward to show you our data lake. It's very exciting.
Hey, thank you, Juan. Yeah, let's get started. So, Juan, I know that we have the customers review data in the data lake. So I've been told that there are multiple teams now are using that data to empower their business users. So RAL being a data-driven company, getting that data and combining that data with the other data that is there in the data warehouse is going to be super helpful. So I did email you the location where this data is located. This is the product reviews data. So I'm just wondering if you would be able to help me how I would be able to, I know this data is already there in the data lake. So if you can help me how I would be able to get access to this data, how I would be able to analyze it, and also how I would be able to take this data to a form that I would be able to share it with my end users. So if you can help me with that, that'll be great.
Sure. So let's check the data lake together. You mentioned the data is stored in our data lake S3 bucket already. So let's first examine the data if it's there. Yeah, it does. Great that the data is already stored by product category, and for all the categories here. Oh, cool! It even stored in Parquet format already. That saved me a lot of work.
Oh, that's pretty cool. Yeah, and Juan, so I see that you are using some kind of a browser tool to go and query this data. So it seemed to be an interesting tool. I mean, always in the past, to access anything in the AWS, for example, to examine my own S3 buckets, I always use the console. So I went to the console, and then I would go and download or view the data that's there in the S3. But this one seemed to be a different tool. So what is this tool?
Yeah, this tool is called Jupyter Notebook. I'm using the SageMaker Jupyter Notebook, which can be easily integrated with AWS SDK and some SQL library, so that I can not only run all the bash command to access all the AWS service through AWS CLI, I can also run the SQL command here directly to examine the query result. I can also using the Python code with Bottle3 to access pretty much all the AWS service I want to. So it's very convenient for me to run experiment when I testing ETL pipeline or testing some conversion. I can quickly do everything here without switching between the console page.
Wow, that's interesting. Yeah, definitely. I think I was not aware of this. So essentially, what you say is I will be able to use the notebook tool based out of the SageMaker to just access any of the AWS services very easily, right?
Yes. So as long as you grant the SageMaker role with the proper permission to the service you want to access, and then you will be able to access them within the Jupyter Notebook.
Pretty cool. And so you mentioned about the data, so the product review data. So it looks like the data is there already in the data lake, and you seem to have run a list command on the AWS S3. But I mean, I'm not quite familiar. What is this Parquet format?
Okay, good question. So the Parquet is a common open file format. More specifically, Parquet stores data in columnar. So instead of traditionally, data is stored row by row. The columnar format group each column and then store the whole column together. By grouping the same column together, there's the same data type and usually same pattern, so that the data can be compressed very well. So that's why usually the Parquet data is much, much smaller compared to the text format.
I see.
And because it's an open file format, so a lot of tools support that, and all the AWS Analytics service also support that, so that you don't lock into a proprietary file format. You can use whatever your favorite tool to access it. And with the columnar format, it's also very efficient to run analytics because the query often just access a small set of the columns so that you can just read those needed columns instead of read the whole row, whole data set.
Ah, very interesting. Okay. So I think then for our analysis today, where we are going to run some analytical queries, the Parquet format is going to be certainly be very helpful in running efficient queries, I believe.
Yes. So we verified that the data set is there. It's already in our data lake. So now let's try to use Redshift Spectrum to access this data set. So Redshift Spectrum is a feature of Redshift. It's kind of extend your Redshift data warehouse to the data lake, allow Redshift to access the data stored in data lake directly. So I'll just show you in a second.
Okay. Yeah, I've been using the Amazon Redshift based data warehouse to perform all the analysis. So it's very interesting to see you can use the Redshift Spectrum to query the data directly from the data lake itself.
Yeah.
So
as
would that mean that would this also load the data into the Redshift, or you're querying directly from the data lake?
You don't need to load the data into data warehouse. As you can see here, all I do is just create the external schema, point to the database in our data lake. And then all the tables will be populated automatically. So this is the demo Parquet is the data set we just examined. So there's no loading process here. And here I'm going to run the query so that you can see we can access the data set almost immediately. Wow, this data set also quite big.
Wow, is that 160 million rows? Wow, that's a lot of data.
Yeah. Yeah, let's also look at sample a few rows to see that if it contains enough information you need.
Okay, yeah, thanks for pulling that out. So what I see here is I have the marketplace, I have the customer data, I have all the product related information, along with all the different review data. And also seems like there is a lot of historical data also in this particular data set. That's going to definitely be helpful to do all the trend analysis on this data. Yeah, certainly this data is going to be super helpful. Yeah.
Okay, great. So I want to also let you know that you can actually create the view on top of this data set and leverage Redshift Spectrum if you need to do certain aggregations, processing. So those processing can be pushed to the Spectrum layer to do much faster there at much higher scale there to finish the query as soon as possible. So for example, here, I just create a view on this data lake data set directly with some aggregations. Now I can just query this view using Redshift Spectrum. so that all the aggregation that we list for the view will be executed by Redshift Spectrum against the data stored in data lake directly, and to give you results very quickly.
Okay, that's pretty cool. So what you're doing is like you are running actual analytical queries on the data directly that is there in the data lake. Is that right?
Yes, exactly.
Okay, that's pretty cool. Yeah, and so one thing, so as you might know, last time you helped me set up the customer data set on the data warehouse. So that's again used by our business users a lot.
Yeah.
So I know that, I mean, as you might know, that data is already there in the data warehouse. So it'll be very insightful if I can combine this the product review data with the customer dimensional data so that I can slice and dice that data. So is that possible?
Yeah, absolutely. So one of the big advantage of the Redshift Spectrum is it extends your data lake, the data warehouse to data lake, allow you to access all the data combinedly as a whole. So for example, you can easily join the data lake dataset with the data you already have in your dimensional table, in your data warehouse table, and you can run the aggregation on top of it to produce the result. So the Redshift will be smart to know that which data set is stored in S3 in data lake, and using Spectrum to process that and do the rest of work within Redshift to merge the results together. So as you can see here, I actually not only execute the query there, I also store the result set back to a Redshift local table. So you can really easily get data, access it, and if you need it, you can still store them back in your data warehouse.
I see. Wow, this is super cool. So as you could see here, what you're doing is you're taking the external data, which is the demo.parquet table, and combining that with the customer dimensional data, and then you are creating a table, a summary table, to get the rolling reviews for the last 30, 90 days. And then you store this data into the customer trends table. So I think that table is going to be super helpful. So I could use this table to run any further analysis. And also the other bigger advantage I see is like I could directly open up this table for all the business users and also create my dashboards using this particular table. Is that right?
Yep, absolutely.
Yeah, that's pretty cool. And yeah, and I also see the query is already able to run there. So I think I'll be able to use this query now directly in my in the Redshift data warehouse. So the other interesting use case. So the other day, Miguel stopped by at my office, and as you know, Miguel is a data engineer, a data scientist who is trying to get some who was trying to build a model based on the customer reviews data. So he had been telling me that if there is a way that I was telling him about this particular project where I'm building dashboards, and he said that he would also be interested in getting this insights into the data so that he would be able to combine the data with the other data sets that he has and be able to easily build machine learning models that will be super helpful in predicting the trends with our customers, the product interest trends with our customers. So is there an easier way to share this data with Miguel, our data
Yes.
scientist?
Yes. So Redshift has a command called unload that allow you to unload any query result back to S3. So for example, here is an example that shows the query that we just used previously that join both the data lake data set, customer review set with the customer information and produce some analytics result. And you can unload the whole thing back to S3 data lake. what's more is the Redshift Unload support Parquet format. Remember, the Parquet is collinear format that allow analytics to run very efficiently. So you can unload the result directly to Parquet format, which is open file format, make it easier shareable. And Unload also support partition, so which allow you to partition the data horizontally based on whatever the columns that you choose. So for example, here we use the product category in case that you want to just run analysis for a specific category. By partitioning the data by category, that allow you to read just that part of the data so that your analysis can run much quicker.
Okay, so what you're doing here is essentially you're putting the data back to the data lake, so that it becomes really easy for me, for any of us to go and share this data within our organization, right?
Yes. Yeah. Okay. So the query is done now. Let's just take a quick look if it's indeed in the Redshift property. So here you can see that's all my data lake. It's in my data lake repository, and it's partitioned by product category, and it's stored in Parquet format.
Wow, that's super cool. Yeah. So I'm super excited. So how we had a raw data set, the customer reviews data, and we are able to take the data, analyze the data, and at the same time combine the data with the existing data warehouse data and produce another the customer trends data, which I could now share it with the data scientist as well as with the other parts of the organization as well within a few minutes. Yeah, that's super cool. So also I saw that you had used multiple services. So would you be able to also give me a little bit insights, the different services and the overall architecture that you used for this analysis?
Yes, I'm happy to. So here is the very simplified architecture diagram. You can see that the source, regardless what many different sources that you have, either it's a relational database, it's a streaming data, or if it's just a flat file, or it's log from the web application. And those data can go landed into the S3, the central storage for the data lake. With the data landed into the data lake, and you can use, we use a Glue here to manage the schema. So in this demo, we just access the Glue to get the data catalog. Glue also provide the ETL capability that allow you to easily transform the data, prepare, clean the data to make it ready for analytics use. So once you have the data ready, and your analyst team can easily search, find the data set they needed, as what we see here, just by pointing to the data lake, you will be able to see that all the table you have permission to view and then run analytics there. And there's multiple different analytics tools, such as Redshift, Redshift Spectrum, Asana, that allow you to access those data stored in data lake directly. And then they can use the data lake as a medium to share the data set, share the analysis result easily, and also for further machine learning training, advanced analytics need.
I see. So, so another cool thing is you are able to access pretty much all these different analytical services within a few clicks using the notebook that you showed me, right?
Yeah, I love that too.
Oh, yeah.
Okay.
Yeah, thanks a lot. I mean, this is super helpful. I'm going to use the customer trends data to create some dashboards for all the business users.
Oh, great. So would you mind to show me how you do that? I'm always interested to see, with all those data sets, how your analysts to show the visualization to gain some insight and to use that to get the business decision.
Absolutely, I would love to. So as you might know, RIL, our company, is a data-driven company. So pretty much all our business analysts, business users rely on the data to make any of the decisions, day-to-day decisions. So essentially, sharing this data is super critical, and for them to make those timely decisions for our customers. So I would love to show you some of the how I would be able to like take this data that you just produced and create some of the dashboards. So yeah, definitely, and how easily these dashboards are used by our end users without needing to know all the complexities with the data that is there in the data lake.
Great. Looking forward to it.
Yeah, sure. Let's go. Let's do it now.
Yeah.
Thanks, Juan, for creating the customer trends data. So what I did was I use AWS QuickSight. So QuickSight is a BI visualization tool. So this is used by all our business users to get analytical insights into the data. So what I did was I was able to get this data set. I was able to connect to Amazon Redshift data warehouse and be able to get this data set into the QuickSight. So what I'm going to show you is like some of the visualizations, typical visualizations that our business users use to go and get insights into the data. So as you could see, this is like the products reviews data, which have been combined with the different customer dimensional data. So let's see one interesting insight, which is pretty commonly used by our business users and gets a lot of interest is like geographically, where are the reviews coming from? Okay, so let me show you that. So let me go and create a new visual. So what I'm going to do is I'm going to build a geospatial visual. So what I'm going to do is there are two dimensions which I'm going to pull. One is the customer state dimension.
Okay.
And the other data set that I'm going to pull is the reviews, the rolling reviews for the last 30 days. So let me make that as my metric that I want the visual to plot.
Oh, cool. It can mark those in the map directly. So
That's
we
right.
can easily see like which state the product is more popular.
That's right. So as you could see, the size of the dots show where the most reviews are coming from, which states the most reviews are coming from. So as you could see, I pulled this information for all the different products in one place.
Okay. So is this possible to drill down if I'm more interested in a specific category?
Absolutely, yeah. That's very easy to do. So what I'm going to do is also pull on this other dimension, which is the product category dimension. So now what's going to happen is it's going to plot the relative sizes of the product reviews split or sliced by the different product category.
Wow,
So,
that's cool.
yeah. But let's say that I want to also like look into a particular product category. For example, let's say I want to only filter out the homes category. So what I'll be able to do is I'll be able to click on this filter. So I'll be able to create a filter for the product category.
Okay.
And then, so what it's doing is it's trying to create that product category. So now pretty much all the product categories are there. So what I'll be able to do is I'll be able to just pick the home category and apply it to my visual, then what's going to happen is now it's going to show me a visual which is just for that home category. So as you could see, Kentucky, the state Kentucky gets the most amount of reviews for the home category, followed by Texas.
Oh, that can help our business analysts to know that that's the popular market for that home goods.
That's right. Yeah.
Oh, this is very helpful. Much easier to read than just those numbers. Your guys' job is easier than mine.
Absolutely, I would agree. Yeah, it's very easy for me to share this. So once I produce this, and I'm going to work with you to create a data pipeline to go and refresh this data. So as the data gets refreshed on a daily basis, this dashboard is going to be automatically be refreshed.
Cool. I'm happy to help.
Thank you. Is there anything other interesting facts that you would want to see from this data set? I'm more than happy to show you.
Oh yeah, I'm always want to see the trending of the product. Does it like become more and more popular? More people buy it, or does it kind of going down? So this might help us to see that where we should pay attention, we should take actions.
Yeah, absolutely. It's very easy to like do that with a few clicks. So what I'm going to do is I'm going to create another visual. So this time I'm going to use a trend chart, a line chart.
Mm-hmm.
Then what I'm going to do is on the x-axis, what I'm going to do is I'm going to use, since I'm interested in like a historical trend, so I'm going to pull the review date.
Okay.
And also, let's say I want to like see the last 90-day rolling ratings, average rating. So when I pull in those two information, so you would see a trend of how the reviews are trending across these different dates that we analyze this data. Mm-hmm. So the interesting fact here is, as you could see, there have been a lot of reviews that have been coming during the March, April timeframe. Okay. And probably this is like some of the sales that we had been running, promotional sales.
I remember we had some campaign running at that time.
Exactly.
Those like draw a lot of attraction.
Exactly. And so it had been pretty, afterwards, it had been pretty like constantly trending on those reviews later on.
Mm-hmm. Got it. Wow, this is very powerful.
Yeah, absolutely. I would love you to use these dashboards if you think them they are useful to you as well. Yeah. It's very easy for you to get insights into the data and see what our business users are saying as well.
I will. Thanks.
Thank you.